Welcome to the Rogue Journal Club, where we tear studies apart so you don't have to. The Rogue Journal Club is a ScioSophia production, featuring long-form discussions of peer-reviewed studies published in academic journals and their connections to society. I'm Adrian.
And I'm Gina. We'll be your hosts.
A journal club is when academics at universities get together to talk about papers.
But we've gone rogue. We're going to do Journal Club our way. Join us.
On this episode of the Rogue Journal Club, we discuss the article Population Attributable Fraction of Gas Stoves and Childhood Asthma in the United States. The article appeared in a 2023 issue of the International Journal of Environmental Research and Public Health. The lead author is Taylor Grunwald. Break out the gas stoves.
Oh no.
We're not going to set anything on fire, we promise.
This time. You know what? I accidentally left my range. I have a gas stove and I left it on by accident with just the gas, and we had to open all the doors and the windows in the house and go outside. And I actually went on ChatGPT and asked it to help me calculate the ppm of propane that was probably in my house as a result of leaving it on for 20 minutes at the typical discharge rate of an average stove. And so it was a really wide margin of error. So it could be anywhere from 18 ppm to 300. So 18 is below the limit of what your detector would, the carbon monoxide detector would pick up.
Yeah.
And then 300 would be you're all going to die, get out now. So ChatGPT was not as helpful as I had hoped in that regard.
That is a very wide range of error. But then again,
it was very, because I adjusted the time. So the difference between having it on for 20 minutes and 30 minutes was enormous. So I guess maybe it increases exponentially if it concentrates, if there's no ventilation. So don't leave your stove on like an idiot. It was one of those things where the flame goes out, but the knob wasn't closed all the way. And so it just I smelled it when we were eating and I was like, I smell gas. We have to do something. And then I thought, oh, it was just a little bit cracked. So they are not for the faint of heart, gas stoves, but they are good for the culinary reasons.
They are very good for culinary reasons. And just gas stoves. I mean, if you've got the interior stove, or you're into the oven kind of part of it,
Mm-hmm.
The interior stove. Yeah.
The oven.
The oven is what we get there.
For a second there, I was like, wait, what is she? Oh, anyway.
The word just wasn't occurring to me. I apologize. But no, it's just if you have a problem and the gas builds up, but the burner, the pilot light isn't on the inside of the oven, but your stovetop is on and lit. If you let the gas build up, but then you open the oven door, you do get an explosion. This has happened before to me and to folks that I know, and happened to my father when he was growing up. So it's kind of
how big of a fireball do you get? Did you get burned?
It depends. It depends on how long you let it build up, and what's the time of that. But when my father was younger in the family, they had an issue where they'd accidentally let it build up, and you get blown across the room by the dang thing when it catches on fire when you open the door.
So you said this happened to you? Did you get hurt?
No, I didn't get hurt. I wasn't as close. I was doing some charity work actually many years ago, and it was just one of my colleagues one of my friends who was there with me. He was standing right by the oven door, and he was fine. He got might have been minorly singed, but we didn't leave it accidentally running that long. So
that is terrifying, and part of me wishes I didn't know that, but no, it's good to know that stuff, because I'm kind of a space cadet when it comes to those things. So I now ever since then have double and triple crazy person checked the knobs and everything. So
mm-hmm.
Yeah, I mean, but you can't beat it for cooking though. We have a pizza stone in our oven, so we crank it up to 500 and put pizza right on the stone and make it like the pizzerias, and then the fast heat up is the electric range wouldn't be able to handle the kind of cooking we do. So the
No,
gas stove is probably here to stay, even though these results are actually pretty interesting. So,
yeah, and if our listeners haven't figured it out, we are talking about the dangerous things of gas stoves. Um,
yeah, so you said that there was some news coverage on this. I didn't
yes,
catch
so
that.
a while back, so I picked this study out a while back because it was referenced by a Washington Post article, and this was way back when the whole news kerfuffle came out that the Biden administration was looking into banning gas stoves.
Oh, really? I didn't realize that. That's news to me.
Yes, they were thinking about it under the auspices of, fighting climate change, not the other things that like what we just talked about with the fireballs.
Are gas stoves that much of a contributor of greenhouse gas?
Well, when you're burning, when you are burning propane, you are producing a little bit of
Oh, yeah, I know. I just mean how much of a slice of the pie is it compared to like automobiles and commercial buildings and all those
anywhere
big.
near as much as an automobile or just the general thing of your house, with energy usage and things like that. So it's nowhere
Okay.
near as much. And one of the reasons it's nowhere near as much is it's not in anywhere near as many homes. It's not even in every house in the United States compared to like an electric range or something like that. And I mean,
Yep.
gas stoves are nice, but the electric range is the most common, kind
Yeah.
of stove in
Yeah,
the
we had it specially installed. We have like a propane tank out back that's specifically for cooking. It's not for heat or anything else. It's just dedicated to that. And we're in a rural area, so we're not tied into the natural gas system that I would if I was in a suburb. So that's a different gas. That's methane, I think,
yeah.
right? And
Methane
yeah.
is considered a greenhouse gas, but it's lesser concern than carbon dioxide is.
Yeah, that's right. I did know that, I think. And then probably I don't know. Actually, I don't know enough about the chemistry of this stuff. So let's just dive into the study and then we can talk about all that.
Yes, this one is not about carbon dioxide. This is a study that's one of the reasons the this was a Washington Post opinion piece that was basically along the lines of, "Well, we should ban gas stoves because XYZ thing." And this was one of the articles they linked off to say
Mm,
proof of that. I don't
mm.
this is one of those cases to me where I don't necessarily think that the journalistic hyperbole is is entirely worth it. But here is the article title. This appeared in 2023, actually, so it is actually quite recent, in the International Journal of Environmental Research and Public Health. Um, Population attributable fraction of gas stoves and childhood asthma in the United States. Lead author is, I think you say, Taylor Grunwald. I think.
Grunwald? Yeah. Yeah,
Grunwald.
I'll go with that. Yeah.
um, then I can read the abstract if you like, just to get us started.
Yeah, do that. That would
Okay.
work.
Indoor gas stove cooking is associated with an increased risk of current asthma among children, and it is prevalent in 35% of households in the United States. The population level implications of gas cooking are largely unrecognized. We quantified the population attributable fraction, PAF, for gas stove use and childhood asthma in the US. Effect sizes previously reported by meta analyses for current asthma were utilized in the PAF estimations. And for those following along, I'm skipping over all the numbers in the abstract. Um,
Yeah, just probably we can get into the numbers later.
yeah, we'll get to those, I'm sure. The proportion of children less than 18 years old exposed to gas stoves was obtained from the American Housing Survey for the US, and states with available data n equals 9, so 9 states. We found that 12.7% of current childhood asthma in the United States is attributable to gas stove usage. Or is it use? They said use here. I want to say usage, but anyway, the proportion of childhood asthma that could be theoretically prevented if gas stove use was not present varied by state, from 21.1% in Illinois to Pennsylvania's 13.5. Our results quantify the US public health burden attributed to gas stove use and childhood asthma. Further research is needed to quantify the burden experienced at county levels, as well as the impacts of implementing mitigation strategies through intervention studies. So, in
Mm,
other words, we're on childhood asthma. with gas stoves.
Yeah, this is personally relevant to me because we're hoping to expand our family at some point in the next couple of years. And we also have a gas range, as you heard from my stupid story at the beginning of how I filled my house with propane accidentally. I laugh, but that was actually a really stressful night. I was pretty freaked out by it. So,
I'm sure it's
um,
humorous in hindsight, but
yeah, so this study is I don't know if I necessarily doubt the conclusion of it. I think that the policy implication that you talked about of wanting to ban stoves, I think maybe a little bit bombastic. I
a
couldn't.
little overkill.
Yeah, I think it's a little bit premature. So I guess we can talk about what they did. Do you want to go through that at least? A
As much as I understand it, because I think you and I were talking beforehand that I'm not 100% clear with exactly what population attributable fraction is and how it's calculated. So we're
Yeah, I think
both maybe struggling a little with that one.
I know I'm going to try my hand at explaining what my husband and I had sorted out earlier today when I was looking at this. I had just needed another brain to bounce this off of because I've seen equations with this form before, and it's just been a couple of years since I've really done statistics. So I was like, I know this means something, but I can't put my head around it. So, um, but yeah, I guess to put it in plain English, I think the population attributable fraction is just how many uh, cases of asthma can be attributed to gas stoves.
Right.
So when they mean population, I think they mean the population that has asthma of children.
Right.
So uh, so
And
I guess they figured this out based on the relative risk of getting asthma if you have a gas stove in your house, and they pulled those risk ratios from other studies.
yeah.
And then the gas stove use, like, so they looked at, you know, how many homes in the US by state have children and gas stoves in them. So that was their broader data set, and I think they constrained it more by wanting to, so that the top of that equation is looking at how many children, sorry, the proportion of households with children exposed to gas stoves. So that's like, if
This is the question I had about this
yeah, it's
thing.
really hard to explain without like a chalkboard.
Well, but here's the thing: the proportion of households with children exposed to gas stoves. I don't know that. This is where I'm wondering is how does the American Housing Survey really go into that much depth to ask folks if you have a gas stove and you have a child?
Probably they do. Yeah, because I think it might be. Well, I guess we can look up the American Housing Survey.
Yeah, and
Let's try that.
I was just looking up the a definition um of excuse me of population attributable fraction just for heck of having a formal definition handy. Um, what journal is this though? I just don't know. BMJ Publishing Group. So it's something in epidemiology. I know that. Written by an assistant professor of epidemiology and a professor of statistics in medicine. Much statistical analysis seeks to identify associations between exposures and outcomes. The population attributable fraction is an epidemiological measure widely used to assess public health impact of exposures in populations. PAF is defined as the fraction of all cases of a particular disease or other adverse condition in a population that is attributable to a specific exposure. PAF equals O minus E over O, where O and E refer to the observed number of cases and the expected number of cases under no exposure, respectively. So,
Yeah, that makes some sense. The way that we were reasoning it out was to decide, okay, so what makes PAF 0? So plugging in values that would make nobody's asthma is attributed to gas stoves.
Right.
So that would mean whatever P is, however many kids live in houses with gas stoves, if the relative risk is 1, that makes P 0, which makes the whole thing 0.
Yeah.
So that would mean if 1 means that it doesn't matter one way or another. So that so 1 is 1 to 1 is essentially what that
Yeah,
means.
it's 6 or 1/2 dozen or the other if you get if
Yeah.
you get asthma, a childhood
Yeah.
asthma.
Like if you're if you're in a house with a gas stove or if you're not, your risk of getting asthma is the same.
Right.
That it's like a 1 to 1. So that would make the whole numerator 0, which would make PAF 0, and that would mean that there's no relationship, that there's no cases of asthma can be connected to gas stoves. So they figured out that it's not 0, it's actually 12.7%. So whatever the relative risk was that they used, they didn't say that it's from that. You have to go look up those sources that they gave us. They didn't actually publish it in their manuscript, and it's not in supplemental, so they didn't say what the relative risk was that they used.
Yeah. Where did they? First, we sought to update the effect size estimates by identifying peer-reviewed manuscripts with the title review. Effect sizes were reported for current asthma in North America and Europe combined, weighted by inverse variance, n equals 10 studies. The odds ratio is 1.34. Were utilized in PAF estimations. So we combined effect sizes. So it sounds like what they used was this odds ratio thing and
Yeah.
then converted it back to no, actually, because odds ratio, I think you could use as a relative. You could use it as the relative risk itself. The way
Yeah,
the ratio is calculated. So
it's just a different way of looking at the same information.
yeah,
Like relative risk is a percent and an odds ratio is a ratio of 2%, I get, yeah.
it's a ratio. I mean, it's a ratio of two numbers, and it's the odds that something would happen given something else.
Yeah. But they're so one is just a percent and the other one is a percent over a percent.
Yeah,
Yeah. So, but you can get the same information from that. I remember doing these in school, but it's been like 4 years now since I took that class and I can't remember anymore. But they I guess they made it like a model where they ran the calculation 10,000 times and then got distributions.
hmm
So then they just took the mean of those distributions. So this is where I don't know enough about stats to know if that's legit or if they're over
yeah.
interpreting it.
Let me read that again. Note that we use the combined North America and Europe odds ratio. Yeah, so they say odds ratio for the relative risk in this equation, as childhood asthma in the US remains relatively rare, affecting 1 in 12 children. So it's one thing is childhood asthma is already really rare.
That does make it a statistically tricky thing then. When it's rare, then you get a lot more like wobble. Yeah.
Yeah, because that's why they had to use North America and Europe is because in the US it's so rare they just didn't have enough sample. We
Yep.
repeated this calculation 10,000 times to create distributions of PAF nationally for each state using the same combined odds ratio for national. Well, that's one thing because the odds ratio is not necessarily the same in between in a state compared to nationally, but that's
Yeah.
one thing to make. We then took the mean of these distributions and calculated their 95% confidence intervals to estimate the PAF of current childhood asthma attributable to gas stove usage. Calculations performed using R, my favorite programming language. Um, I do almost everything I do statistics wise in R, so
I like R too. It's fun.
very much fun.
Yeah.
See, this is what's weird about it is because if I were a reviewer, I would have knocked them for that because there's a lot of different ways you could do that kind of 10,000 times thing. You could do like a Markov chain Monte Carlo kind of thing to get those distribution things, which is I suspect what they ended up doing.
That's what I thought it sounded like. They didn't say that specifically, but the idea of running a calculation a bunch of times to get a distribution sounds very close to that. So,
Yeah, and you just for those folks listening, Markov chain Monte Carlo is a handy way to get many, many, many things over and over and over again. So you can get a sense of the statistical distribution of something, and you basically run the calculation over again with something ever so slightly different every time that you run it. And then
Yeah.
it starts to fill out what the actual distribution of the results are. And, hopefully, if it's something that is a nice, like normal distribution or something like that, you get the highest density in the middle when you run your 10,000 odd things as they did here. And that gives you the sense of, oh, the mean is this. And we've got a 95% confidence interval. And
Yeah,
so
I guess like a super dummy way of explaining it. I don't mean to say dummy. I'm like a dummy as well. I like the dummy explanations. They make everything make more sense. It's like if you take 10,000 different classrooms of students and you give them a test, in 10,000 times, most people are going to get a C, a few people are going to get an A, a few are going to get a B, then there's like a couple of F's and D's, but the bulk is in the BC area. So you could look at 10,000 classes and see if that pattern repeats itself or if it's drastically different from class to class. And then you can figure out what the average probably is over like 10,000 classes, but the classes are all theoretical in the computer. And so you just run them like with code instead of like giving tests to actually 10,000 students, which or classrooms, which would not really be feasible. And in this case, it's really not feasible because you're talking about families with children and gas stoves in the whole country, and you can't go out and ask them individually that many times. So this is a way. Also, they do this when something is rare. I think this is a trick.
this is a way to get more sample when you have something that is a really rare occurrence to begin with. And as they already noted, I mean, childhood asthma in the US is relatively rare still. So that's one thing with that. Yeah. Yeah, so I would have knocked them because they didn't talk about how they did the 10,000 times replication. Because, yeah, there's Markov chain Monte Carlo, there's just traditional old bootstrapping. You could do it that way. Um, Heck, you could have done this with Bayesian if you knew, if you had some kind of sense of what the a priori, what your okay. Bayesian stats, for those who don't know, is very different from classical stats, which is what most folks learn is classical stats. Bayesian stats is where you basically have something like the PAF, for instance. You have some kind of a priori thing of what you think the distribution of that variable is. You have some data which helps you make a likelihood function. And basically, what it is your posterior, your now informed distribution of what you think that variable is. Posterior equals prior times likelihood. So that was the thing that was drilled into my head many, many times in a Bayesian stats class.
Yeah, I didn't get that much of that. So that's a good way of explaining it. I think it's a little jargony though. I bet a lot of the listeners probably still didn't understand what you said.
Fair enough.
but but
Um,
it's also hard. I think it's hard to convert that into everyday speech because there isn't a lot of everyday word synonyms for all that stuff. It
no,
can be tricky.
basically think of it the best way I can think of is you think of it this way. Before you go into a situation, you might have some kind of inkling about how it's going to unfold at the end,
Right.
right? But then you're in the situation itself and it unfolds differently. And as you come out of it, you think you have a different inkling and thought about how it unfolded. That's the idea. Your a priori thing is your assumption of what you think it's going to be like. You get your data in the situation that you're in. And so you have your a priori times your data, and that
Mhm.
gives you what your inkling is on the outside, your
Yep.
posterior, as it were.
And then so classical statistics that we all learn in like Stat 101 and freshman year of college, that looks at it. Explain how that's different then from what you said. Like how would you look at the same situation using the classical method?
So where Bayesian is different from classical is oftentimes with classical you have to make a very specific assumption about some of the distributions there. Like you're saying, it's normal with this amount of spread and this amount of that. With Bayesian, you
Okay.
don't have to do that as much, but the data helps you figure that out
Hmm.
in a lot of ways. The other thing is that with a classical stats kind of thing, and this is way nerdy in the weeds kind of thing, you end up with, shall we say, it becomes more difficult to estimate uncertainty about other things that are going on. So, like in a Bayesian sense, what you could do all the way down is do the same kind of thing on the proportion and the relative risk also at the same time, and let all of that uncertainty translate into PAF. But you can't
Yeah,
do that as easily with classical stats.
yeah, the classical method, that's like when you read a study and it says there's no statistically significant difference, that's the classical statistics that uses basic, like standard.
Classical stats is hypothesis testing about what
Yeah.
things are and how they unfold, but with a Bayesian thing, you're actually using the data to inform that a lot more.
Yeah, you can almost go into it a little more agnostic. Like you don't have to have a super clearly laid out hypothesis. Um, but it's harder, I think, to do it the Bayesian way. And I'm not,
Oh, yeah. It is
yeah.
much more difficult to do it in a Bayesian format.
And I think that's
Time is
probably why they
patient
teach the
expensive.
other thing to students because it's a lot more clear cut. And it's older. I think in terms of like the advances in statistics, I think the classical way is the classical way because it was first
Yeah.
and it made sense and it
I
still
will
does. I think it's still used very widely. So
Yeah, no, classical stats is the most widely used kind of stats, and in case there's a statistician listening, I apologize if I butchered the description of Bayesian stats because it is not my fullest expertise. I've taken classes in it, but I don't work with it all the time. So yes, I apologize. You feel free to correct us in the comments.
yeah, feel free to well actually go for it. I like that because then I learn things.
Mhm.
So, but yeah, for the non-math nerds in the audience, this conversation, if you are not following it, it's okay. What this is hopefully showing you is that this stuff is not simple to study. And it may seem like it's a simple question. Do gas stoves cause asthma, right? Like, is that a that's not a complicated question in like grammar wise. It's not like a, you could think about that. But actually testing it to where you really understand whether or not that's actually happening, like this kind of thing is just a drop in the bucket because you also need to look at it from all these different perspectives, and statistics is not just one thing. There's a lot of different approaches and all of them have setbacks, all of them have advantages, and you can bias your results based on how you approach the statistics. So it's important. This is why one study isn't enough to make a policy decision, because you need to look at it from all these different sides. Plus, what they also are not talking about here is even if you find an association, you still need to do all of the medical studies that look at how the mechanism for how propane and methane would cause asthma in children. You need more than just the association to be able to make a policy decision like banning gas stoves, which I can see why people are mad. So yeah, but we all have a different like level of evidence that we're willing to that we need to have in order to make a personal decision, and
Exactly.
that is not something that science can tell you.
Although
You have
I
to.
will say they
Yeah.
probably use something in classical stats because now I can see like 95% confidence intervals. Common That's a pretty common thing with classical stats to have confidence intervals like that. So it's probably something in there they didn't get into the Bayesian stuff.
If it's epidemiology, it's probably classical. This sounds like something. It sounds like fairly straightforward, just because the question is not complicated.
Yeah,
So,
yeah. But still,
um,
that's something I would have knocked him for if I was peer reviewing because I don't know how you did your 10,000 replications.
yeah, this paper is only like 4 pages long, including the references, and it only has 9 references. So it's really it's a
Maybe short.
short paper. It's very brief. It's missing, to me, it's missing a lot of explanation, which was frustrating. So
Yeah, yeah.
I did think it was interesting. So they talked about how this is the first time anyone's ever broken this down by state. And just like kind of an aside, I was looking at this. So Illinois has the highest burden, followed by California, New York, Massachusetts, Pennsylvania. And then Texas, Colorado, and Ohio all experience burdens of disease around 10%. And Florida's the lowest at 3%. And it seems like it's related to just how many households have gas stoves. So in Illinois, 79.1% of households with children cook with gas, but in Florida, it's only 9%. So that's really interesting that there's like state differences that are that drastic in the use of gas ranges. And that just makes me wonder why that is. Like, is it an infrastructure thing? Is it a cultural thing? It's interesting to me.
Might be an infrastructure thing because I just imagine it's probably easier in Illinois because a lot of the gas lines would all be underground.
Oh yeah,
What?
Florida doesn't have much of an underground. I grew up there. I'm well aware of that.
Yeah, because it would be yeah, you go too far underground in Florida, you end up in water. Um,
hmm Yep. Yeah, I lived at sea level for my whole childhood basically. So and then now I'm at sea level again in Delaware. So just cool, just not as hot, which is great. Um but yeah, so the state difference is interesting, and also it's just, this goes to show you that just the number of households where children cook with gas has an effect on the risk. That's what that, doesn't that sound like what they're saying? That like you get,
I'm just processing the other thing you said. You said where children cook with gas.
oh, did I say, I'm sorry. I think I mashed like three sentences together in my head where, oh, where households with children cook with gas. That's where I got that from. I was like reading and thinking at the same time, which is never a good thing.
No, no,
So
no. I think I understood that you were trying to say that, but I
yeah, it's
processed
like
it for
what,
a second.
yeah, it's like walking and chewing gum at the same time. I have a hard time with all those things. Actually, I think I can walk and chew gum at the same time. I'm gonna have to try just to be sure. Um, yeah, anyhow, I'm weird. So
No, it's okay. It's okay. I just did take a mental pause to make sure I processed what you said right.
yeah. So the state level population attributable fractions differ due to varying exposure to gas stoves. So this is also talking about,
See,
so that so that percent, 12.7% of current childhood asthma in the US is attributable to gas stove. If that percent changes based on how what percent of households in your state have gas stoves, that, I'm having a hard time wrapping my head around that. So is it not 12.7%, or is this just a mundane detail that I'm having a brain fart about?
no, I think it's a fair point because this goes back to the problem that I had in that they're using one singular odds ratio for national and state.
Mm,
For that relative risk side of it. But because the American Housing Survey has the granularity of the data that it does, then they can get into in Illinois figuring out that 79% of the households there 79% of the households where there are kids also cook with gas, where it's only 9% Florida. So I think the difference here in the state versus national calculation is in the national one, they're aggregating it together and saying, whatever X percent of households with children have gas stoves and cook with gas. You could determine that from the American Housing Survey.
mhm.
I pulled it up to look real quick, and I was like, "Damn, that's expansive what they put in that survey."
Yeah, I know. I looked it up too. They do ask a lot of stuff. I mean, it's the census, so I guess that makes sense.
Yeah.
So
But I think the number with the 79% and the 9% and then 21 to 3% down with the actual burden of it, that has to do with that has to do primarily with that P number in
mm,
there that changes, not the relative risk number
mm,
because they held that fixed the whole time. The P
yeah,
number actually changes with proportion of households with children exposed to gas stoves. That's
yeah.
the number that's drawn from the AHS, the housing survey.
I think it just hit me what my brain fart was about, and I think I get it now. I always try to find like the English language sentence to say to go with the numbers because that's just how I think. So your risk of gas stove caused asthma is lower in states where they don't use a lot of gas stoves.
Yeah.
So fewer of the cases of asthma in children are going to be caused by gas stoves in states where there aren't that many of them to begin with. That's like kind of actually a mundane Like, of course that's true. So
Yeah, that's the one where you're looking at the authors of the study and being like, "Well, no shit, Sherlock."
yeah, so I think it's just easy for your brain to take that 12.7% and say, oh, you have a 12.7% chance of getting asthma if you're exposed to a gas. So that's not what that means. That 12.7% means out of all of the people who are kids who have asthma, 12.7% of those asthma cases are caused by gas stove exposure.
So
So,
we can do a back of the hand kind of calculation here. Now, because in the previous section they just said, um, we use the combined North America and Europe odds ratio for relative risk in this equation as childhood asthma in the US remains relatively rare, affecting 1 in 12. So 1
mhm,
in 12 is your initial percentage of kids who have
yep.
asthma. And then so what, 1 in 12?
Yeah, I was about to bust that out. Hang on.
Let's do some math.
Yeah, what is the US population right now of and how many kids are in the US? Let's see.
So 1 in 12 is 8% of kids.
Yeah. Yeah, it's less. So there's 73 million children in the US times 8%.
Mhm.
So that's 5,840,000. So it's like 5 million kids have
Have asthma
asthma
to begin with. So
to
what
begin with.
they're saying is 12%, 12.7% of that 5,000,000 number is attributable to gas stoves being using gas stoves. There we go.
So that's 635,000 kids have asthma today that wouldn't if not for gas stoves. That is technically what the math of that is saying. So wanting to so this is the idea of like if we ban gas stoves and they went away and into outer space and no one ever had one again, then we would reduce the asthma disease burden among children by 12.7%. This is the idea behind the ban recommendation that I guess the study authors even make at the end.
Yeah, I think
I
that was
kind
one
of.
thing they said. Yeah.
Yeah, they say, given that this exposure is preventable, our study demonstrates that known mitigation strategies will lessen childhood asthma burden from gas stoves in states with elevated PAFs. Wait, that's not what I wanted to read. Um, we posit that there are two interventions: removing the source by replacing gas cooking with cleaner alternatives, to reducing exposure through source ventilation, example, range hoods. So then they talk about how okay, ventilation reduces it but not eliminates it. The only way to eliminate it is obviously to eliminate the source, which is the get if we assume that this 12.7% thing is true, which we just have to assume that while we're reading the paper, but it may not be, reducing exposure through ventilation is like second best to getting rid of the stoves.
Yeah.
Moreover, and they also say why range hoods are not practical because some houses are not outfitted for it. Some of them aren't installed right because they just basically blow it back into the room just higher above your head. The ones that are fancy that chefs have that they actually vent outside, you have to have like your house modified for that, so it's hard.
Oh yeah.
um and then they may not work that well, all that stuff. So
Mhm.
so yeah, they're even suggesting that intervention, which this is something that always bugs me about papers that make recommendations at the end. They're like, they make the most simple recommendation, like, oh, we just found that this thing is bad, so let's get rid of it. That's the answer. And it's like, well, hold up there a second. You're not a policy expert. You are an expert in like epidemiology. Let's get a few more people talking about what the best solution is. I think it just, there's no humility in some of these conclusions where they're just like, it's bad, get rid of it. Like, or we need more laws. That
Well,
these are kind of the things that I think academics tend to just go to because it's simple and they're not used to thinking about policy because that's not what they do.
yeah.
And so
Yeah.
it always annoys me when I see this. I'm like, here we go again. Another like broad sweeping recommendation that journalists are going to latch onto and make everybody mad. And that's exactly what happened. So it's like, yeah,
Yeah.
that's
No.
my pet peeve with all this stuff. So
It's
Uh,
mine also, and also in particular because they I give them credit that they acknowledge certain limitations because one of the things they talked about is, our interpretation of the PAF as the proportion of preventable disease rests on the assumption that, for one, exposure to gas cooking among children is orthogonal to other risk factors such as exposure to tobacco smoke, meaning there's nothing in interaction there that could also be causing the asthma. So
yeah. Yeah,
me
if you drill down to the source of the risk, the relative risk calculations, these are correlations. They're based off of correlations from
right.
studies, like where people, you know, okay, gas stoves. So here's all the houses with gas stoves. Are they more likely to have asthma? So you've got, let's see, an example of like you live in a house without a gas stove or with one. Are there more asthma cases in the gas stove houses than in the non-gas stove houses? And so that's just a correlation. Those gas stove houses could also have smokers in them because maybe gas stove houses are older, and maybe uh, your lower income populations might be more likely to live in a gas stove house. Those populations also are more likely to smoke cigarettes. There's all kinds of different things you could look at. Um, and that's just, I just pulled that one out of the top of my head. There's probably a gazillion other things that I haven't thought of because I
Yeah.
don't study this. So
Well, I mean, also, like, how many folks are burning scented candles?
yeah,
I mean, that's
that's,
a random one, but potentially
yeah, I
it's
actually, that's funny.
right.
My husband asked the same thing. What about scented candles? So it's funny. I hate scented candles because they leave like an oil film all over everything if you burn them long enough. Like, yeah,
Oh, I didn't
it's,
know that,
yeah,
but
because that aromatic has to go somewhere, you know?
fair enough. That's a good point.
So yeah, and it settles on things. And actually, this is really gross. I was cleaning my kitchen. I climb up on the counter to clean the tops of the cabinets, and there was like sticky goo with dust stuck in the sticky goo. And
Mm,
I figured out that it was evaporated cooking oil from like us living in this house for, you know, 7 years or 8 years or something like that. And from frying and from pan frying and things like that. We make a lot of Indian food, and there's a lot of deep frying involved because it's awesome. So the vaporized cooking oil floats up and then it settles on things and it's sticky. You know how the outside of your deep fryer will get sticky after
yeah,
a
yeah.
while? It's from oil like settling there. So, and it's really hard to clean it off. So
Ugh.
I went at it with like rags and brushes, and it was like this gray stuff with dust stuck in it. It's all clean now, but man, that was a rough time. So yeah, that stuff is in the air. It's not good for you. So obviously this is an important study to like, I don't doubt the conclusion in general, but I think just the recommendations are very extreme. I think we need to understand more about what's behind those correlations just to make sure that the relative risk ratios that were used to do this calculation are actually based on something.
Mhm.
You would need to do um, medical studies to actually figure out what the mechanism is for how propane and methane would cause asthma. That's something that we would need to be convinced of, I think, before we go and make a broad sweeping recommendation that like propane and
Well,
methane are
and
bad. So
yeah, and this is my kind of wondering because I was thinking that too because correct me if I'm wrong, but I had always thought, and this is where I'm wading out of my depth. I fully admit that with with this because I am not an expert in medicine, but I thought asthma was more so triggered by particulates, not by gaseous vapor.
yeah, see that I don't know either. I have no idea. So that would be a question that could be asked if it hasn't been asked. Like, what is the role of vapors in triggering asthma? Is there a role? Do we even know that?
Yeah.
Like, you see the correlation, but that doesn't necessarily mean that there's a known mechanism for how that's working. It could
Well,
be,
yeah,
yeah,
and now that I think about it, there's two different things here because of course there's whatever triggers an asthma attack, and that may be particulate thing, but whatever causes a child to develop asthma in the first place.
right.
The only
That's
thing that
those
I
are two
could
separate things.
Yeah, the only thing I could think of with respect to the gases is of course it does something to degrade your lungs.
Yeah, and I think isn't asthma like an autoimmune disease, kind of? Or it's an inflammatory condition. Maybe it's not necessarily an autoimmune disease.
Do some live searching.
Oh, it's not. It's an inflammatory condition, not autoimmune, but there might be an autoimmune component.
Yeah, lung
That's
disorder characterized by narrowing of the airways, the tubes which carry air into the lungs that are inflamed and constricted, causing shortness of breath, wheezing, and cough. From the Mayo Clinic.
Yeah, I guess that's probably a reliable source.
Yeah, so this asthma is a condition in which your airways narrow and swell and may produce extra mucus. This can make breathing difficult and trigger coughing, a whistling sound, wheezing, when you breathe out, and shortness of breath. For some people, asthma is a minor nuisance. For others, it can be a major problem that interferes with daily activities and may lead to a life threatening asthma attack. Asthma can't be cured, but its symptoms can be controlled. Because asthma often changes over time, it is important to work with your doctor to track your signs and symptoms and adjust your treatment as needed. Okay. Yeah, so
Yeah. Yeah, I think I forgot what I was going to say. A good friend of mine, her son has really severe asthma where he needs like a nebulizer, and he's been in the ER many times. They know him first name basis kind of thing, and he's young. He's like 9, I think.
mhm.
So, um
So here's a little bit more because causes. It isn't clear why some people get asthma and others don't, but it's probably due to a combination of environmental and inherited genetic factors.
right.
Asthma triggers exposure to various irritants and substances that trigger allergens can trigger signs and symptoms of asthma. Asthma triggers are different from person to person and can include airborne allergens such as pollen, dust mites, mold spores, pet dander, or particles of cockroach waste. Ugh, didn't know that.
Yeah,
Respiratory.
I guess early childhood stress is also linked to
That's what they're
um
saying down here is one of the triggers for an asthma attack can be really strong emotions and stress.
yeah, and then this is a study in a respiratory journal, and I've read about this in a book, like a psychology book. But adverse childhood experiences such as abuse and neglect are associated with subsequent immune dysregulation. So it's a correlation again, but some studies show an association between these experiences and asthma onset, although significant disparity in results exists. So chronic stress in early life is associated with an increased risk of asthma onset. But of course, there's always extra factors that play into why a stressful early childhood might be associated with that without it being the cause. Um, like there is evidence that adverse child experience increases the impact of traffic related air pollution. So there's a lot of things that cause asthma, and like we really don't know. So this study, in and of itself, without a mechanism, is pretty speculative still.
Oh yeah, definitely.
And I think it's a an important conclusion. It gives us the signal that there's something to study and that
Yeah.
there's something to wonder about. And I think that's good. And I'm glad it was published. I'm glad it was done. Uh,
No, yeah.
Again, to me, this is the angering outcome of science journalism. So, commercial for my future book that I hope I write someday.
Yeah, no, I agree with you. It's the utter frustration that you're making an overarching policy recommendation that is way too general when you probably shouldn't, particularly when you as the epidemiologist probably don't take into account the many other trade-offs and things like that.
Yeah.
Like one of the good things about gas stoves is that if the power goes out, you can still cook with it. You just need a
Yep.
match because you can't use the electric lighter.
Yeah, and I'm kind of at this point becoming a little bit of an unashamed doomsday prepper. And we live in a rural area, and we just got a manual flour mill. It's super cool.
Nice.
like a hand crank one. Man, that is a good core workout, and arms. Like, yeah, anyway. Yeah, Adrian and I are like into fitness right now. So yeah, manual grain mill. It's 0 calorie pizza. You grind the mill and burn the calories, and then you eat the pizza. It's a net zero gain. So yeah.
Awesome.
Yeah, it's the flour that burns calories for you. So anyhow, that was a major digression, but
How many
yeah,
digressions do we go on a regular show? So
at least 30. I think yeah, the propane, I mean, I don't want to give up my stove. I think I would need more evidence to be willing to give up the gas range. I hope that they don't make them illegal. That would really suck. We'd have to like really rework our kitchen then. That would be expensive. I
yeah,
hope Biden pays for it then. Is he gonna is he gonna hook us up with some funds to redo our kitchen then?
I yeah, probably not, but
Yeah.
because no,
That
I mean,
was
if I have an electric range where I am right now, and I would really, really prefer to have a gas one, to be honest.
yeah. Yeah, they work better, especially for stir frying and things with oil, like because then your food's not like sopping. You have to wait for the oil to heat up longer, and yeah,
Yeah. No, it
I
heats
know.
things up so much faster, and the other thing, of course, is when you turn the gas off, the heat goes off too. So, like, the electric ranges, it retains the heat in the ring for a long time.
Yeah, you have to like move it over to the other burner. Yeah. Yeah, and it never gets as hot and all that good stuff. And you can't roast marshmallows over it. Okay, I only did that one time and I don't know why, but I just really wanted to.
Yeah. I mean, the
Yeah.
broader point you're making is just like, yeah, this is all great, but don't forget that you don't necessarily have the right to use science or some kind of science sometimes to justify superseding a personal decision of a family.
Yeah, I think that this is some topic. This is a thing that you and I have talked about privately and on the show and on your show. Is this like sort of authoritarian bent of the way academics talk about things, and they are in an echo chamber themselves where most of them are paid from government grants, and so they really like government as a solution to things. It's just what they know, and the idea of like a free market or states' rights, all those things, like they associate that with like bad people. Those are the bigoted old conservatives that like have these sort of naive beliefs that the market can solve everything. Well, no one said that. So there's there's a lot of other ways you can solve these problems. Um,
Government
you
is
know,
not a solution to all ills.
and we have a fairly sophisticated air filtration system in this house because it was a remodeled house. And we're really cognizant of the fact that there's old aspects to this house and we just want to keep the air clean. There's probably fungal spores and dust that moves through. And so, and we live in the woods and there's dirt everywhere. And I have an underground basement farm and there's dirt in there too. So we have invested in a sophisticated air filtration system that's not taken into account. Ventilation is good, but what about purification?
Yeah.
And then is methane natural gas stoves? Is there a difference between propane and methane in the effect on asthma? I wonder too, because we have a propane stove, but maybe the natural gas is better or worse. They're different chemical compounds. So how, would one be more likely to trigger? And so in this study, the different kinds of gases are not separated out. Like that would be a detail that would be really tough to study in this kind of. They wouldn't be able to get a hold of that data. I don't think the Census Bureau asks, do you have a gas range? Is it natural gas or propane? I doubt that they have that level of granularity.
Yeah, and I was just looking just to satisfy my curiosity because I couldn't remember the chemical formula for propane.
I think it's 3 carbons.
Yeah, no, it's C3H8 if I remember correctly now.
Yeah.
Yeah, C3H8 and methane is CH4. So it's
Yeah, propane takes a little more energy to break down because it has more bonds, it's more reduced.
right,
Um,
right. But it is one of the key byproducts of uh, burning propane is carbon dioxide and water vapor.
yeah. Yeah, I guess that's true for all carbon-based fuels.
Yeah, and I think anything that's carbon based, you do get carbon dioxide.
Yeah, like wood.
Yeah, like when methane is burnt in air, it produces carbon dioxide and H2O.
Yeah. Yeah, I mean, here's another question. What about wood burning heat and like oil heat? What about oil heat? Okay, those are also so is this all fossil fuel based fuels are triggering asthma? Why would they
Well,
so
I would think the wood burning one would be worse actually because you
yeah.
get the flying ash and things like that. You don't get that with burning just straight methane gas or propane
Yep.
gas. So,
Yep. Yeah, the particulates are a big that there is a mechanism known for that it can trigger asthma attacks. But then of course the question is, does it cause new cases?
right.
I guess if you have to be genetically susceptible, you have to have the genetic susceptibility in order for any of the environmental triggers to have an effect on you.
Mhm.
And
See,
yeah, so
this is the other thing they don't get into is that are these kids who would have had asthma otherwise because of the genetic side? They really didn't control for the genetics part of it.
yeah, you couldn't, not with this kind of study
No,
anyway.
no, but I mean, it is an important caveat really to it. I don't think
Yeah.
they mentioned that if I remember correctly, but
Yeah, I think they're basically just assuming that it's like, this artificial like sphere that represents a child, that there's not like any, there it's just a point. It's a data point on in the spreadsheet. So
and
I guess
admittedly they have to make that assumption, right? Because they can't necessarily control for
yeah.
absolutely everything that could affect a child's.
Yeah, and I think actually, as you say that, I wanted to also point out that the criticisms are actually that, at least on my end of things, I'm not making to this study. I don't think this study is bad actually at all. I don't think they needed to change anything. Maybe they could have added some more information on paper for novices, people who are outside the field to understand what they did. But like, I'm more critical of the news coverage of the study. I think they put too much faith in this one study rather than, so really my complaints are to the readers. When you see one study, it's looking at the problem from one face of the problem, and so you need to look at the other ways that people have looked at the same question to be able to really make a decision.
Yeah,
And it's not like your decision would even be different. It may end up being that we decide gas stoves are bad for kids and they cause asthma. We may end up deciding that, but you can't know that from one study. And I think the all of the different confounding factors and variables that Adrian and I have been talking about, we're telling this to the news and the readers. Remember, there's all this other stuff. You can't just make a decision off of one study. This is just one view of the problem.
yeah. I just found I was incorrect earlier. It's not an opinion. It's not an opinion piece, but I did just find the Washington Post article. How the humble gas stove became the latest flashpoint in the culture wars.
That's
Published.
a very flashy title. As a former editor of a website, I give that study a thumbs up, or that title is high quality.
Mhm.
Uh, but
Published.
yeah, Washington Post.
Yeah,
I
published.
mean, yeah, it's probably technically not an opinion piece, but it might as well be.
Yeah, it's pretty close. I mean, it was talking about the particular thing, and apparently, the Republicans, when this initial thought came out that this was going to happen, went after the Consumer Product Safety Commission, which would be the one entity that would ban gas stoves if that were the case. But yeah, they didn't say they would do that. But this study is cited. This study that we just reviewed is cited. Oh goodness knows where is it? It's way, way, way down toward the end of the actual article. Yeah, while the issue has become ensnared in partisan politics, scientists say this is one of those things that
Scientists say.
scientists say a growing body of research shows that gas stoves pose a threat to the planet and public health. Wait a second. A peer-reviewed study published last month found that gas stoves are responsible for roughly 12.7% of childhood asthma nationwide, on par with childhood asthma risks associated with exposure to secondhand smoke.
Hmm.
A separate study published last year found that gas stoves used nationwide, but primarily in California, Illinois, and northeastern states, release far more methane than previously thought, even when they are turned off. Methane, a potent planet warming gas, traps about 80 times as much heat as carbon dioxide during its first 20 years in the atmosphere.
Hmm. So they're looking at a lot of different things, and the asthma thing was just basically like, oh, by the way, it's also bad for kids.
Yeah, and yeah, they got a map here in the article that was how many Americans cook with gas? It depends upon the state. 70% of California households have gas fueled ranges in cooktops or ovens in 2020, while Florida just 8%. So it's actually gone down in Florida since they did this particular thing.
The
Because
Floridians were like, no, no, I don't know. It probably is due to the lack of an underground. They're just not as common there.
yeah, and like in Delaware, it's 27%. Um, New York, it's 62%. DC, surprisingly, is 62% also. Uh,
Hmm.
40% in Maryland. New Mexico is 50%. Illinois, 67%. These are the 2020 numbers. So that what they had in the survey was the 2019 numbers.
Ah,
So it has actually gone down a little bit in a bunch of these in a bunch of the states that were mentioned.
interesting. Well, it definitely is worth keeping an eye on this topic. I think it's, if you have kids and you have asthma risk in your family and you're planning on having children and and you suspect this could be an issue, and you have a gas range, I think I wouldn't make a hasty decision, but I think it's definitely worth keeping an eye on this topic.
Mm.
I certainly will be. So, but
And
hopefully the government doesn't make my decision for me before I can think it through.
yeah, the decision is really up to you. I mean, that's the thing really is you gotta.
I mean, if they're framing it like it's a climate change thing, I feel like I definitely, you and I have talked about climate change a lot. You study that for a living. It's real, it's happening, it's a problem. Is it the end of the world? Probably not, but it's still a big problem for human civilization. And is that something that we should be like ready to just give up control over our individual lives to solve? I think that that's a mistake to think that.
No, I do think and this is just my personal opinion on it. The issue and concern I have with the climate change stuff is yes, you need to do things about it. I
Hmm.
do not think it is a very good it should not be used as an excuse to give government officials control over everything. Should absolutely
Yeah.
not be used as that excuse. If only because I think that will end worse.
Yeah, and it may not even solve climate change,
No.
to be totally honest. Like the big, sweeping, hasty, frantic decisions like that can backfire. What was the thing that Jacob had read about? Some of his colleagues had talked about there was like this mad scramble to plant a ton of trees, and then it turned out the trees were releasing aromatics that actually were greenhouse gases, and they ended up making the problem worse. It was something like that. And this wasn't even like in a conservative news site. I think it was just something that happened in the journals. It was just a discussion among scientists. I need to find that now.
You'd have to show me that one another time because that's hysterical if that's the case. I'm sorry.
Yeah, hold on. I don't know if what I'm searching is gonna. Okay, planting new forests can do more harm than good. Yeah, maybe it's this BBC article here. The Trillion Trees campaign. Go away, pop-up ad. I'm trying to read. Okay. Um, okay, let's see. Oh, there's like a bunch of stuff about. Okay. Looking at 11,000 soil samples taken from afforested plots, the scientists found that in carbon poor soils, adding new trees did increase the density of organic carbon. Anyway, I'm gonna I'm gonna have to find that. I don't think this article actually is it, but I will find it for you.
Okay.
Tree planting campaigns can totally backfire. Futurity, yeah, I'll find it for you another time, and we can share it
Yeah.
below for the listeners because it's funny and also upsetting.
Oh yeah. Oh yeah.
So, yeah.
I mean, but that's a good example of how just running off and making an emotion laden decision. It's not to say you can't have emotions. Obviously, we all have emotions, and we all are somewhat emotional people. Um, but making a rush decision based upon an emotional reaction to something
Mhm.
usually ends badly.
Yeah. I mean, I am an extremely emotional person. It's like almost bordering on a disability for me. I'm very upfront about it though, because I really do try to live my life not as a slave to that. So it's not easy, but if I can say, don't make emotional decisions, you should listen to me because I know from experience that from doing that, it backfires personally and it can backfire on a broad scale. But I don't need to tell you, lovely people, that because you probably are far less crazy than I am. Wink,
You're
wink.
all
Maybe.
some degree of crazy.
Yeah, maybe we're all in the same club and that's why we're all hanging out virtually right now. Who knows? Um, but yeah, I have nothing more to say on the gas stoves paper. Any final thoughts
No,
from you?
I don't have much either. I'd say it's a decent study. I agree. Like I said, one thing I would have knocked them for in peer review is like you didn't tell me how you did your 10,000 replications. Really, that would have annoyed me because it's a reproducibility thing.
Well, even putting their R code on some supplemental data, like is it top secret? It looks like it was a government funded study. So,
Well, I mean, the only reason I can think of that they wouldn't have there's a data availability statement. Hold on. All data are available publicly as described. Well, that's nice.
oh no, not yeah, the data sets that they used, yes, but the actual like
Sometimes, yeah, sometimes they do some of the journals now will do code availability statements, but they didn't do that here. And I can imagine they may have been sensitive to that if there was anything like identifying,
yeah,
you know.
probably.
Um, but that's a fair ask. I mean, it should be a fair thing to go and ask them for the code that they use to do the result.
Yeah, even a redacted like general flow diagram of their algorithm and like or something. Yeah.
Yeah. So that would have been nice. But no, I think it's a decent article. It's probably one of the more decent ones that we've that we've reviewed.
Yeah, we've really reviewed some clunkers in the past, haven't we? But yeah, this was good. I think it was nice and straightforward. So that's always a nice thing when you can just like read it and understand like what they're going for. And it's not like this, you're like wading through this like swamp of science jargon and, you know, so
Yeah,
good
definitely.
job, authors.
Good job, authors, indeed.
Okay.
Yeah,
Well, I suppose that is all for
that's
this
it. And
show.
don't blow up your gas stove.
Yeah,
Um,
don't leave the thingy on and fill your house full of gas. It's bad.
be a responsible gas stove owner. And in general, just be a responsible stove owner, because I'm sure you can set fires with electric stoves too. But
Yep.
until we next meet, folks, this has been the Rogue Journal Club. May you always stay curious.
Bye, folks.
Thanks for listening to this episode of the Rogue Journal Club. If you want to suggest articles for the show, please consider becoming a supporter of ScioSophia.locals.com. The link for the Locals community is available in the show notes. The Rogue Journal Club is a ScioSophia production. Copyright 2022.